All right, on this question, we've got a bit of a complex situation. We've got a snowboarder going down a 15-degree hill. Trying to draw a picture, right? Then they go horizontally for 10 meters. And then they go up a steeper hill that's 30 degrees. And we want to find the velocity at the bottom of the hill, and then how far can they travel up the hill. Now, to remember, the key thing to note that acceleration on a ramp, A, is g sine theta. So we've got, A in our first case, on our left side, A would be equal to 9.8 sine 15 degrees. And I got 2.54. Technically, that's negative meters per second squared. And I'm trying to find V2, yeah. So V2 squared is V1 squared plus 2a delta x. Now, we knew this, by the way, was 50 meters long. That's also what we knew this. So I can solve for V2 because V1, the snowboarder glides down. She glides, so she, boom, does this. She starts at 0 plus 2 times negative 2.54 times their change in x, which is negative 50 because it's gone downhill 50. And then you play the game, right? This is V2 squared. There'll be a square root involved, but you can solve this problem, I bet, relatively easy. And I get V2 to be 15.9 meters per second. Now, if this is a frictionless surface, there's nothing that happens here, but now they rise at a 30 degrees, and the question is how far will they go? But we have a new acceleration, and that's going to be g sine theta. But instead of putting, 19 degrees or 15 degrees, we have 30 degrees, and this is negative 4.9 meters per second squared. We're going to use the same equation. V2 squared equals V1 squared plus 2a delta x. You have your a here. You're trying to solve for delta x. V1 is going to be this right here, your V2 from your previous one. So that's 15.9 squared. And you're solving, and then V2 squared, and when she stops traveling up, this will be 0. And you know 2 and a, so you can now solve for delta x.